Hey guys, welcome to lesson 4. We are going to be covering Hess's Law today. Let's begin with our learning goal. So I understand that not all reactions can be determined with calorimetry. All right, we've been talking about calorimetry in the last couple of lessons, but it is only used in theory. However, Hess's Law can be used for all reactions. Now, here are the scenarios where calorimetry is not appropriate for us to use. Firstly, a reaction occurs very slowly. So, occurs very slowly. And secondly, a reaction that releases a very large amount of energy. So, it releases very large amount of energy. For example, explosions. Okay, when do you use Hess's law? So we use it when there are no experimental values. So no experimental, let's spell that right, mental values. And if we are required to use enthalpy of formation. So use enthalpy of formation. Okay, next learning goal. I understand that enthalpy change of a physical or chemical process depends only on the initial and final states. Final states. So when using Hess's law, it doesn't matter the path taken to get from reactants to products. Now, a lot of people are going to be like, what the heck does that mean? So I should have had a bit more space here for a diagram, so I'm just going to draw it off to the side here. Let's say we want to go from A to B. This is my initial state, and this is my final state. Now let's say we took a different way. We took the scenic route. So we went to C, then D, then to A. What Hess's law is saying that even though we took a longer path to get from A to B, the pink path and the yellow path are the same because our initial and final state are also the same. So I'll just overlap those. There you go. Okay, so now, next learning goal. I understand that manipulating a reaction will change delta H value. Now, what does that mean? Let's go through some examples. So I have my initial equation here. Okay, so we're going to be referring to this equation as we make our changes. So the first one is saying if you flip the reaction, then this will happen. So firstly, our reaction is going to flip. CD will now go to A plus B. Because we flipped it, our delta H value is going to have a sign change. Okay, so then delta H will have a sign change. Next one, if you multiply the reaction, and I'm just going to say by 2, then delta H will also be multiplied by 2. So I'm going to say we're going to have 2AB plus 2B going to 2CD. So everything is multiplied by 2, including our delta H equals 2 times negative 30 kilojoules, which gives me negative 60 kilojoules. All right, are we picking up on a trend here? Next one, if you divide the reaction, and I'm just going to pick 2 again, then delta H will also be divided by 2. So 1/2 A plus 1/2 B gives me 1/2 CD. Delta H is divided by 1/2 by our original, which gives me negative 15 kilojoules. Okay, so 1/2, 1/2, 1/2, and it gives us our new delta H value. Okay, next one. If we multiply the reaction, I'm going to give you a different one here, 3 over 2 by 3 over 2, then delta H will also be multiplied by 3 over 2. So we will have 3 over 2A plus 3 over 2B goes to 3 over 2CD. Delta H will also be multiplied by 3 over 2, which gives me a new value of negative 45 kilojoules. So 3 over 2, 3 over 2, 3 over 2, we multiply by 3 over 2, which gives us our new value. Lastly, we can do multiple if the reaction is flipped and multiplied by 3. I'm going to just say times 3. Then delta H will have a sign change and be multiplied by 3. So we're going to have 3CD going to 3A plus 3B. So our delta H is going to be 3 times positive 30 which gives me positive 90 kilojoules. That positive is coming from the flip, and then the multiply by 3 is there, which will give us our new value of 90 for our delta H. Okay, let's do an example. So, for example, I'm going to say I can manipulate multiple reactions to create the desired reaction and determine the corresponding delta H value. So in this example, it says calculate delta H for the reaction 2A, 2B plus A2B2 producing 2A, 3B2. This is what I mean when I'm talking about the desired reaction. So I'm just going to read left to right. First thing is we need to find that 2A, 2A2B. So that's this reaction here. And it's already in the right order. The only thing we need to do is double it. So I'm going to take this original reaction and I'm going to go 2A, 2B, going to 4A plus 1B, because a half times 2 is 1, plus B2. Delta H is going to be multiplied by 2, which gives me positive 80 kilojoules. Then the next reaction, so we've got that, we need to have A2B2. So I'm looking for that. It's right here. I need to flip this reaction. So I'm going to flip this reaction. So A2B2 going to 2A plus B2. So that gives me a delta H that was going to experience a sign change. So it goes from negative 80 kilojoules to positive 80 kilojoules. And then the last one, I need 2. Sorry, I'm just going to grab a different color here. So we're looking for this one. We need 2 of them, and we need it on the product side. So I see it here. I need to flip it, and I need to multiply it by 2. So 3 times 2 gives me 6A. B times 2 gives me 2B2, producing 2A, 3B2. Delta H is equal to, what we're going to do is multiply it by 2, and we're also going to give this number a sign change, which gives me minus 100 kilojoules. So let's recap. The first reaction, I'm going to highlight in yellow. The first reaction, what we did was we flipped it. Oh, sorry, not flipped it. We doubled it. So we doubled. The second reaction, I'll take it in green. What we did was we flipped it. Okay, so we flipped. And the last reaction, I'm just going to take that in green, take this in yellow. The last reaction, let's grab another color here, how about pink? The last reaction was flipped and doubled. Flipped and doubled, or multiplied by 2. Okay, now what we got to do is we got to take the sum of these reactions. So I'm just going to see how things cancel out. So 2AB, I don't see 2AB on the product side, so I'm going to write that down. Actually, I'll write it in blue. 2A2B. Great. Okay, I'm going to work on the reactant side first. Plus A2, A2B2. Okay, let's go to the green section on the reactant side. So now I have 6 A's. So 6 A's. I can cancel out 4 of those A's. Then I'm left with two A's. Then I can cancel out those two A's, and I have no A's on the reactant side. Okay, then I'm going to take see how many B's I have. Well, I have a B here, so that takes away one of my B's. And then I have another B2 there, so it takes away my other B2. Okay, now going to our products, I have 2A3B2. I see none of those on the product side, so I'm going to be able to keep that as is. 2A3B2. The last thing I need to do is add up my delta H's. So my delta H is equal to 80 plus 80 minus 100, which gives me plus 60 kilojoules for this reaction. This is my final reaction.